Now let us look at the general procedure for doing the DH representation of any robot. The first step is to assign the reference frame to each joint. How do we do that? For understanding that, let us take an example. This is one of the robots that we had already studied, and if you remember, we had said that there has to be a universal frame, then there has to be a frame for each joint. Now we have missed certain joints in between, but anyway, we are having here four frames: U, R, H, and E. And what is important is to get the tool E with respect to U. So if you remember, we had said at that time that we would like to have the transformation matrix of E with respect to U. And for that we had said that we can get that if we find out what is the transmission of R with respect to U, what is the transmission representation transformation matrix of H with respect to R, and similarly what is the transformation matrix or transformation matrix representation of E with respect to H, and R gets cancelled, H gets cancelled, and finally we will get E with respect to U. The same thing we have to use in all the other cases. In previous module we had used a different method, and here we are going to use a DH method. So the first thing in DH method is to assign these frames for each and every tool, and for that we follow certain rules. To understand that, let's look at one particular case. Now imagine that there is a robot which is having many joints, and the joints are interlinked with each other with the help of links. Now this is just three successive joints that we have considered here, and let us imagine that all of them are revolute joint. There can be translatory joint also, or prismatic joint also, but here we are going to consider that it is revolute joint. With that in mind, if we are going to consider this joint, so let us say that it rotates like this. Similarly, this joint also rotates like this joint also rotates like this. So for each and every case we will have different rotations, and based on this we have to find out the frames for each and every of these joints. Now the DH method basically always concentrates on the reference frame, that is for the center and the next successive joint. So this is just for drawing what should be the reference frame here and the reference frame here. And what we do in DH method is we try to go from this reference frame to this reference frame. That is what we try to do. So from the middle joint we try to go to the rightmost joint. That is what we are going to do here. So the first step is that we have to define the axis of each and every joint. So first we will name the joints. Let me name the joint as N, the next one as joint N plus 1, and the next one as joint N plus 2. This naming convention we should always take care, because the number of joint will decide what is going to be the transformation matrix. So the first one we will name as joint N, the second one as joint N plus 1, the third one as joint N plus 2. The link will go from joint N to N plus 1. That link we will call it as link N. Similarly, the link that connects joint N plus 1 to joint N plus 2, that we will call as link 2. Now we will draw an axis. So here I have drawn an axis. As you can see, this is the same axis with which the joint is rotating. So I had already told that, if I am going to consider this as the rotation direction, then I will consider the axis of rotation as this one. Similarly, I can have suppose this is rotating in this direction, I can have again this as the axis. But what is the direction? So if I am going to draw this as the direction, then this will be z axis. If I am going to draw this as the direction, this will be the z axis. So that I have to decide. So for that, what is the rule? The rule is very simple. We always follow the right hand rule. So what does the right hand rule says? The right hand rule says if this is the direction of rotation, if this is the direction of rotation, so if this is the direction of rotation, then the z axis should be this one. And that is what we are doing here. So here, suppose the direction of motion is in this direction, then according to right hand rule, I will have the z axis to be this one. Now remember, as a convention in dh representation, we always consider that the z axis of the joint n will be named as n minus 1. This is joint n plus 1, this one. Then the axis of that will be Zn. So whatever is the joint number, we will take a number behind that. That is going to be the axis. So if it is the first joint, I will take the value as Z0. The Z axis, I will name it as 0. If my joint is the sixth joint, I will write the axis as Z5. So this we should not forget. But the angle with which we are rotating, that we will always name it as the same joint number. So it is joint n, so it is theta n. Similarly, this is theta n plus 1, this is theta n plus 2. This naming rule we should not forget, because otherwise all our calculations will go wrong. So always remember, for joint n, the axis will be Zn minus 1. So whatever is the number, 1 minus that number is going to be the z axis. So once we have done that, next we have to find out an. What is an? An is the perpendicular distance between Zn minus 1 and Zn. See, whatever be the direction in which Zn minus 1 and Zn is oriented, we will always be able to find 2 points, one in Zn minus 1 and another point in Zn, wherein we will be able to draw a distance of an, and that an will be in such a way that it will be perpendicular to Zn minus 1 also and Zn also. Now there can occur a condition, if suppose Zn minus 1 and Zn is going to touch each other at some point, then that point there will be an an. The only thing will be that since both of them are touching, an value will be equal to 0. So that we should always remember. This an is also called as a common normal. Why? Because it is normal to Zn minus 1 as well as Zn. So an is a common normal between Zn minus 1 and Zn. Similarly, between Zn and Zn plus 1, we will find a normal which is an plus 1. So always remember that the link is n and an is also having a subscript of n. Similarly, here the link is n plus 1. So here the common normal is having a subscript of n plus 1. So it is an plus 1. Now there can occur some conditions. As I said previously, there can be a case where Zn minus 1 and Zn, both of them are touching at one point. That point is where the an will be, and in that case an will be equal to 0. So an can be 0. We should not forget that an can be 0. There can also occur a condition where Zn minus 1 and Zn both are parallel to each other. In that case, what will happen? You take any 2 points there might be many ans that connect between Zn minus 1 and Zn. It does not matter, you draw it anywhere where you want. Generally in that case, what people follow as a rule is they will always try to keep the the common normal in such a direction that it is same as the previous one. Suppose if Zn and Zn plus would have been parallel, then I would have chosen an plus 1 to be from this point to the next point, and that is important. Now the next case that we do here is we extend an a little bit forward, and when we extend it a little bit forward, we will get the x-axis of the z-axis. So I will get xn here, and I will get xn plus 1 for zn plus 1. And this is also very important, because here we have defined the x and the z axis for this joint, and we have also defined what is the origin. So where is the meeting point? That meeting point is the origin, and where we are having the z axis and x axis, we can always draw the y axis. Because why? Because y axis is perpendicular to both these axes. So I'm not going to draw y-axis here. It will be clearly understood that y-axis can be drawn perpendicular to xn and zn, and similarly here also the y-axis can be drawn perpendicular to xn plus 1 and zn plus 1. Okay. Now this is what we have done for finding out the frame of Zn xn and the frame Zn plus 1 xn plus 1. Remember, here we have not drawn the frame for the previous joint or the first joint. I always told you that DH method always talks about the central joint and the next successive joint, because our aim is to take this frame, which is Zn xn frame, to Zn plus xn plus frame. That is the aim. We have to take that frame, we have to take this frame Zn xn and coincide it with the frame Zn plus 1 xn plus 1, and for that we will be able to write the transformation matrix.